When we want to multiply polynomials together, it's just an extension of our rules of exponents that we learned in earlier sections or parts of our textbook. Remember that if I want to multiply 3x squared times 4x, we multiply the pieces that are alike. That's our commutative property, our associative property. We get to regroup things and put things together. So 3 times 4 is 12. X squared times x is x to the third because we add these exponents together, or this is understood to be a 1. If I have 3x squared times the quantity 4x minus 7, okay, so a monomial like 3x squared, one term, times the sum or difference of terms, okay, then we get to use the distributive property. When we hook the 3x squared and the 4x together, we determined already that that's equal to 12x cubed. 3x squared times negative 7 gives me negative 21 for the number, and then the x squared gets to tag along for the ride. So multiplying polynomials is just going to be the distributive property over and over and over again. Now maybe instead of just having a monomial like 3x squared times a bunch of things, maybe I have two binomials and I want to multiply them together. So I have two terms in the left expression and two terms in the right expression, and they're added together or subtracted, and so now I've got more pieces involved I've got to deal with. Remember the word FOIL helps us to get through this multiplication problem, where the F in FOIL stands for first. The first term in each set right here are 4x and 2x. And if we multiply 4x times 2x, we get 4 times 2 is 8. X times x is x squared. The O in FOIL stands for the outside or the outer terms. The two that are on the outside are the 4x and the minus 5. When we multiply 4x times minus 5, we get negative 20x. The I in FOIL stands for inside, or the inner terms. The two terms on the inside are positive 3 and 2x. If we take positive 3 times 2x, we get positive 6x. The L in FOIL stands for last. The last number or expression or term here and here are the positive 3 and the negative 5. Positive 3 times negative 5 is negative 15. When we start this product, we find our first and our outside and our inside and our last products. But notice here we're not completely done. When we look at those 4 terms that still remain, some of them are like terms, which means we need to combine them together as best we can. Okay, now, oftentimes our outside and our inside terms are alike. They're the same degree, they look the same, and so we can combine them together, but not in every problem that we do. Okay, but always look and simplify the best you can once you've spread everything out. So how about 2x squared minus 5, okay, they are all looking the same, and x plus 1. Go ahead and pause the video here in a moment. Do your first and your outside and your inside and your last. Combine like terms as you find them, and then turn the video back on and see if you're right when you're done. So the first terms give us 2x cubed. And our outside terms give us 2x squared. Our inside terms give us negative 5x. And our last terms give us negative 5. Forgot to finish my thought. Okay. Now when we look at this, we notice that none of those are alike. None of those terms are alike. So once I've distributed and I've used the word FOIL, then I'm done with this example. That's the best I can do with it. Okay, somehow I need to circle my answers. Okay, so maybe I'm asked to multiply 2x plus 3 times x squared minus 4x minus 9. Okay, notice that this time I don't have a binomial and a binomial. I have 2 terms times 3 terms. So the word FOIL is actually not going to help me out at all here, because this guy here, what do I do with him? He's not a first, he's not a last. I can't just ignore him and pretend he doesn't exist. So if I come back up to the 2 examples above and I understand where FOIL came from, then I'll know how to extend that to this example. Notice our first terms here, 2x squared times x, and our outside terms, 2x squared times 1. Notice that what I did there is I distributed the 2x squared to both of those pieces. Up above the 4x, I took it times the 2x and the minus 5. Then when I come back, I took the negative 5 times the x, and then I took the same negative 5 times the 1. I used the distributive property again. When we are multiplying polynomials, we're just using the distributive property over and over and over again. So to find this product at the bottom, I'm going to take 2x and distribute it to every term of that trinomial on the right. When I'm done with that, I'm going to come back to the 3, and I'm going to distribute it to every term in the polynomial on the right. So I'm going to start out with 6 terms, and then I'm going to go back and look for any like terms that might exist, and then I combine them together to simplify my final answer. Okay. Go ahead and pause the video and give this a shot. Do the purple distribution first, and then come back and do the blue ones, and then combine your like terms. Okay, and I'm going to put some checkpoints along the way. All right, so if we distribute the 2x times all 3 terms, these are the 3 pieces that I got. Okay, if you didn't get these 3 terms, go ahead and pause the video again, see if you can find your mistake. When you distribute the positive 3 to all the pieces, you should get 3x squared minus 12x minus 27. And then when you combine your like terms, we should get 2x cubed minus 5x squared minus 30x minus 27. Okay, here is our final answer for the simplified product. Okay. Now notice what I did here when I distributed the 3 to all the pieces, that I came down and I lined up the like terms. And there's not a requirement by any means that you do that for me, but I like to show students that because sometimes if you string all 6 terms out in a line, or 9 or 12 or how many you have, it's hard for your eyes to group and see things correctly. So I like to stack my like terms as I find them, and then it's just a matter of adding vertically to get through that. All right, something else I want to point out and be sure that you've thought about is maybe I'm asked to square something like 3x plus 4. Understand that squaring 3x plus 4, I can cheat here because I still have my rules of exponents from my other video, is not the same as squaring, if I can find the right problem, squaring something like this. Okay, the 3x to the 4th y to the 5th. Okay, I can't just square each piece and take it from there. Okay. When I have a sum or a difference, there's more involved. But remember that what squaring something means. If I'm going to square something, that means I'm going to multiply it times itself. Okay, and most of you will be more correct more of the time, make fewer mistakes if you write them side by side like this and then FOIL. Okay. There is a shortcut formula that by college algebra some students have committed to memory and are good with that. And if you know that, that's fine. If you can expand that in your head and write down the 3 terms, I'm good with that. Okay, but more of you will want to go ahead and write them side by side. Okay. I will just tell you that the answer you should get here, if you want to stop it and work through it, you should get 9x squared plus 24x plus 16. The other thing to keep in mind is, maybe I should have left out the 2, but maybe I have 2x plus 1 times x plus 2 times x plus 3. There is no magic formula or pattern that is user-friendly to do some sort of weird FOIL thing with this. Okay. If I asked you to multiply 5 times 2 times 9, okay, there's no distributive property there. A lot of you would say, well, 5 times 2 is 10, and 10 times 9 is 90, okay, which is true. Or you could say, well, 2 times 9 is 18, and 18 times 5 is still 90. Okay. Or you could take 9 times 5 and get 45, and then take that answer times 2 and again still get 90. If you're multiplying 3 or more polynomials together, again, there's no shortcut for this. You're going to need to pick 2 of them. It doesn't have to be the 2 I circled, but you're going to have to pick 2 of them and FOIL. Okay, and after you've combined your outer and inner terms together, you should get that. And then from there, you get to use the distributive property again and again. Okay. So multiplying 3 or more things, you're going to multiply some together, take the answer, and multiply it by the last. I'm about out of time, so I'm going to go ahead and shut this down now. Thank you. Thank you.